Hello everyone. In the previous video, we have seen about the outliers. What are the causes of outliers? What problem does the outliers cause? And what were the different types of outliers? In this video, we'll be discussing about the outliers detection and handling. As we have seen, the presence of outliers affects the measures of central tendency and variability. So therefore, to achieve meaningful and unbiased data analysis, outliers have to be appropriately identified and handled. Now let us see what are the different methods of detection of an outlier. The first method is to visualize the outliers with the help of a scatter plot. Scatter plot, as we all know, is used when we want to determine relationship between two variables. In this scatter plot, as we can clearly see, most of the data points lie close to each other and follow a specific pattern. But there are 2 points which are very different from all the other points. We term these points as outliers, and therefore we can say that scatter plot can be used to visualize the outliers. The next method is using the interquartile range. We have studied the interquartile range under the measures of variability. So as we studied, IQR is a difference between the third quartile and the first quartile. So IQR is equal to Q3 minus Q1. We can say that Q3 is 75th percentile point and Q1 is 25th percentile point. Now let us see how we can use the interquartile range to detect the outliers. At first, to find the interquartile range, we will have to find the Q1 and Q3. The next step is we calculate the interquartile range, that is Q3 minus Q1. After calculating the interquartile range, we need to define the upper bound and the lower bound. So the upper bound or the upper limit is given by Q3 plus 1.5 times the interquartile range. Similarly, the lower bound is given by Q1 minus 1.5 times the interquartile range. After we calculate the upper bound and the lower bound, we identify the outliers. So if my data value is greater than the upper bound, or if my data value is smaller than the bound, in both the cases, the data value will be outlier. As we can see through this diagram, we calculated Q1 and Q3 in the first step. After that, we got the interquartile range, that is IQR. Using this interquartile range, I defined the upper bound and the lower bound. So this will be my acceptable range for the data point. If any data point lie beyond this range, that is, if any data point is greater than the upper limit or lower than the lower limit, in both the cases, that data point will be called outlier. So using this method, we can find out if a data point is an outlier or not. Another very important method of visualizing the outliers is by using the box plot. Box plot is a very famous plot which is used to capture the summary of data. In the given diagram, we can see a box plot. Box plot contains a box which is extended by lines on both the sides, which are called as whiskers. The box is bounded by Q1 and Q3, or the 25th percentile and 75th percentile value. Inside the box, there is a line which represents the median or 50th percentile value. The line on the left hand side of the box, or the whisker on the left hand side or the lower end of the box, represents the lower bound as we calculated in the IQR method. Any data points which are beyond this minimum value will be termed as outliers. On the other hand, the whisker or the line on the right hand side or the upper end of the box represents the maximum value or the upper bound as we calculated in the IQR method. Again, all the data points which lie beyond this line or beyond this maximum value are termed as outlier. So we can clearly say that the box plot provides us insight about 25th, 50th and 75th percentile value. It also tells us about the median as well as presence of outliers in my data distribution. So that was about box plot. Another method to find out if a data point is an outlier or not is by using the z-score. So z-score is a parameter which tells us how far away a data point is from the mean in terms of standard deviation. Z-score can be calculated using the formula Z equals to x minus mu, where x is a particular data point and mu is mean. This x minus mu is divided by standard deviation. The term x minus mu represents how far a data point lies from the mean, which is divided by the standard deviation, and hence we get how far a data point lies in terms of standard deviation. We will be studying about the z-score and z-test in upcoming videos. For now, if for a particular data point the value of z-score is greater than 3 or it is smaller than -3, in both the cases that data point will be an outlier. So these were the methods of detecting outliers. So after we have detected the outliers in our data distribution, we need to handle those outliers so that we can analyze our data in a better way. Now let us see the methods of handling the outliers. Firstly, if the outliers are present in our data distribution, what we can do is we can straight away delete those observations or those respective rows. We delete the outlier values if the values are present because of some error like data entry or data processing, and only when the outliers are present in a very small number. So that is important. We go for deleting the observation only when we have very less number of outliers. Deleting the outliers when they are present in a large quantity will lead to loss of data. In that case, we prefer other methods. Another method that we can use to deal with the outliers is transforming and binning the values. In this method, we transform the data values so that the effect of outliers gets reduced. A very standard method of transforming the data values is using the natural log, which reduces the variation caused by extreme values. Now let us consider an example. Suppose my data distribution contains values such as 10, 100, 1000 and say 10 to the power 6. I can clearly say that this value is way larger than any other value, and hence I'll call this as outlier. Now if I take log base 10 for all these values, for 10 log base 10 will become equal to 1. For 100 log base 10 it will become 2. For 1000 I will get 3, and for 10 to the power 6 it will be 6. Now as we can see that this value 10 to the power 6 was 1000 times greater than 1000, but after doing the log transformation we can clearly see that the variation in the values got reduced. So this is how transforming the data values help us to deal with the outliers. Another way in which we can transform our data is by assigning the weights to the observation. Similar to transforming, we can also use binning. Binning is used to smoothen the data and to handle the outliers. In this method, the data is first sorted and then the sorted values are distributed into a number of buckets or bins. So that's about binning. The third and a very useful method that we can use to deal with the outliers is imputing. In this method, we impute the outliers by using the values of either mean median, or mode. So let us say if I have a distribution which has a mean of say 50, it has three outliers which are say 300, 500 and 700. So in this method, we replace these values by the value of either mean, median or mode. In this case, I'll be replacing by the value of mean, that is 50. I replace each of the values by the value of mean. So this is how we do imputing. Apart from this, another thing that we can do is we can use a statistical model to predict the values of outliers, and we can impute the outliers using these predicted values. Another method of dealing with the outliers is to treat them separately. Now suppose if we have a significantly large number of outliers. In this case, we cannot delete those entries, right? Because that will result in loss of significant amount of data. So what we can do is we can treat them separately. In this method, what we do is we divide the dataset into two parts. That is, we separate the outliers from the clean data. The approach is to treat both the groups, that is, the outliers and clean data separately, and then we build the individual model for both the groups and then combine to get the output. So that was all for today's video. If you liked the video, please hit the like button and subscribe the channel. Thank you.